Section 15.3, we're going to be adding and subtracting radicals. Okay. And the way we do this is when adding or subtracting radicals, the radicands must be the same and we simplify first, then add the outside numbers. All right. So let's get right into this here. And just as a refresher, when we're talking about radicals, this number is called the index, and this number is called the radicand. All right, so the directions are going to be, so just simplify 7√7 plus 3√7 minus 8√7. Now, the radicands are the same, so we add the outside number. 7 plus 3 is 10, minus 8 is 2√7. It's like saying you have 7√7s plus 3√7s minus 8√7s. How many √7s are there? And there's 2 of them. All right. Or if you had 8√7 plus 7√7 plus √3, you have 15 √7s, but there's nothing else to combine with the √3, so we just leave it alone. By the way, when I say root, that also means square root. So that's how you do those two. Sometimes we have to simplify first, like if we had the square root of 8 plus the square root of 18. The way we simplify these is we write the square root of 4 times square root of 2. This is the square root of 9 times the square root of 2. We talked about this in the previous section. So it's just 2√2s plus 3√2s is 5√2s. We want a little harder. What if we had 7√99 minus the square root of 12 plus the square root of 27 minus the square root of 44? We talked about a couple different ways to simplify. So we could use prime factorization or even just the perfect roots. So the square root of 99 is just the square root of 9 times the square root of 11. Square root of 12 is square root of 4 times the square root of 3. Square root of 27 is the square root of 9 times the square root of 3. And the square root of 44 is the square root of 4 times the square root of 11. So 7 times 3 is 21 root 11 minus 2 root 3 plus 3 root 3 minus 2 root 11. These have the same radicand, so we can combine those. 21 minus 2 is 19 root 11. Negative 2 plus 3 is 1 root 3. We had the square root of 121x plus the square root of 16x minus 16 root x. This is just the square root of 121 times the square root of x. This is the square root of 16 times the square root of x minus 16 root x. This is just 11 root x plus 4 root x minus 16 root x. And math works the same whether it's numbers or letters. 11 plus 4 is 15 root x, minus 16 is just minus 1 root x.
Can I ask something?
Yeah, question.
Where did you, I kind of got confused. Where did you get the 11 square x?
Yeah, so the square root of 121 is 11.
Oh, that's okay.
All right, good question. All right. What if we had 2 times the square root of x to the third minus x times the square root of 64x? So we still have to simplify it. And we talked about simplifying square roots. What we have to do is, this is the same thing as just x to the 3 halves. We talked about this in our last class. And we could write that x to the 1 and 1/2, or just x to the first square root of x to the first. We said this number goes here, the index goes here, and the number on top goes here. Another way we could have done this is we could have written x out 3 times. And just like with numbers, we circle our groups of 2, and then there's 1 left over. So you get the same answer whether you use the shortcut I showed you or whether you just write it out. But the 2 is here. And we'll simplify this. The square root of 64 times the square root of x. Square root of 64 is just 8. So 8 times x times the square root of x is just 8x root x. So 2x root x minus 8x root x is minus 6x root x. Just give me a second to get caught up. All right, and maybe we'll just do one more to wrap this up. And that is the square root of 25x squared plus the square root of 49x squared minus 13 root x. All right, well, the way we simplify this is we do the square root of 25 times the square root of x squared. The square root of 49 times the square root of x squared minus 13 times the square root of x. So this is just 5. And if we're looking for groups of 2, it's just x plus 7 x minus 13 root x. And then combining our like terms here, we get 12x minus 13 root x is just this.